produces a wide variety of electromagnetic holding brakes. The vast majority of these are spring-applied. Spring-applied holding brakes are used throughout many industries. Common applications include medical equipment, robotics, factory automation, servo and stepper motors, elevators and escalators. Electric spring-applied brakes. Electric or electromagnetic direct current single-disc spring-set brakes are the most common type of holding brake produced. Electromagnetic spring-applied brakes are designed to stop and hold a rotating shaft or to simply hold the shaft in place. Their function is opposite from a traditional electromagnetic brake. When no electric power is going to the brake is considered engaged and holding. The two main reasons for using these brakes are safety and accuracy. The key components to the brake are the coil, springs, pressure plate, friction disc, cover plate, and hub. Spring-applied brakes transmit torque via spring pressure and use an electromagnetic field to release the spring pressure. Brakes are engaged mechanically and disengaged electrically. When voltage or current is applied to the brake, the coil becomes an electromagnet. This produces magnetic lines of flux. This flux travels through the small air gap between the pressure plate and the field coil, attracting the pressure plate to the coil and compressing the springs, releasing the friction disc so it is able to rotate. When power is removed from the coil, the pressure plate is released and the springs push the pressure plate against the friction disc, trapping it between the pressure plate and the outer brake cover plate. Since the hub is attached to the friction disc, the hub and the shaft going through the hub are either dynamically stopped or held in place. The difference between the two is that during dynamic stopping, heat is generated, so the brake and friction material have to be sized to handle the energy during braking. With a holding-only application, only the static torque needs to be considered. Depending on the brake and its function, different types of friction material can be used. In most applications, the friction material is free to move over a square or spline on a hub that is fixed to the shaft. There is a slight clearance or backlash between the hub and the friction disc. For zero backlash applications, the hub is directly connected to the spring steel disc. In these types of brakes, when the friction discs are held, there is no backlash movement at all. Backlash can be critical in high-precision applications like medical equipment or microchip processing. Brake coils are normally 90 or 24 volts, but there is a wide variety of specialty voltages available. Different controls can also be used with holding brakes. Over-excitation can provide a faster response. For power savings, reduced current controls are available. Since most of the current is required to reach across the air gap to the pressure plate, once the pressure plate is engaged, current can be reduced significantly to reduce power consumption of the brake. Before performing any installation or maintenance functions, make sure that all power to the machine is turned off and all brake components are at room temperature. Installation. Although there are multiple components inside the brake, most brake assemblies consist of only two major parts for installation. One is the brake body, and the second one is the hub. The first step is to make sure the shaft is perpendicular to the plate that will hold the brake field in place. Although some Ogura brakes allow a slightly larger perpendicularity, most Ogura brakes require that the tolerances be held to 0.002 to 0.004 inches of total indicator runout. The next thing to check is the pilot and bolt circle. These should be concentric to the shaft within 0.006 total indicator runout. Some of the larger units allow for 0.008, and some of the very large units allow for 0.012 inches. The following chart shows exact requirements specifically by model. The difference between the two most extreme measurements of the indicator from anywhere on the surface is the total indicated runout. For smaller spring-applied brakes, insert the hub into the brake and then temporarily connect the leads to your power supply, making sure the connections are properly insulated. The voltage going to the brake should be at the rated voltage shown on the label. Switch on the power to the brake. Make sure your fingers are not near the pressure plate when the brake engages, or they will get pinched. The hub and friction disc should now be free to move. You can then slide the entire hub and brake assembly onto the shaft. For smaller brakes that have a key, insert the key into the keyway of the brake hub and the shaft. Depending upon hub style you are using, the set screw, set collar, or snap ring should be set to prevent hub movement. Most brakes require 3 mounting bolts that are not supplied by Ogura. Insert the mounting bolts to lock down the brake housing. Mounting bolts will vary in size depending upon brake hole diameter and total width of brake body and mounting surface. Once all 3 bolts are tightened, release the power to the brake. For RNBZ0 backlash brakes. RNBZ units. Installation should follow the installation procedures for smaller spring-applied brakes, with the exception of the hub mounting. With the zero backlash hub, it is critical that the brake disc and friction material do not make contact when the brake is disengaged. This is because any frictional contact will result in both accelerated wear and heat buildup, which could damage the brake. RNBZ units should not be used on motors with excessive magnetic centering or axial movement. With the brake body mounted, apply power to the brake. Feel for the most neutral position of the hub to the friction disc. Insert the key into the keyway of the hub and shaft. Once this position is located, lock the brake down via the set screw. If possible, try to slowly rotate the shaft. If any contact is noticed, release the set screw and try to reposition. To reposition the hub, the key may have to be moved if the set screw has caused an indentation. For larger brakes, mount the brake body on the pilot. The pilot can pick up either the ID or the OD of the brake coil housing. Mount the brake body to the mounting pilot via the 3 bolts that are supplied by the machinery manufacturer. Bolts will vary depending upon overall length required and diameter. Tighten down all 3 bolts to manufacturer's recommendation. Depending upon the hub type, there may be a spacer or a step in the shaft required to properly position the hub on the shaft. Other hubs have set screws to position the hub on the shaft. Whichever style brake and hub you have, there has to be some way of locking the hub in place. Once you have determined what will be positioning your hub, slide the hub onto the shaft and install the key. There is a good chance that the hub and the friction disc will not align exactly, so to reposition the friction disc, temporarily energize the brake coil at the rated voltage shown on the label, and then slide the hub into the friction disc, which can be a spline or square depending upon brake model. As an alternative for powering the brake during installation, on the larger SNB and RNB brakes, you can insert a bolt into the 3 tapped holes and manually release the brake for proper hub positioning and installation. Once the hub is installed, don't forget to remove the 3 manual bolts. Make sure the lead wires going from the brake to the power source are properly connected using the machinery manufacturer's recommendations. Don't wrap the lead wires around the coil housing because high temperature from the housing may damage the lead wires. Cycle the brake under normal load conditions. There should be no noise coming from the brake when it is engaged because there should be no movement. When the brake is disengaged, there should be almost no noise. If noise is coming from rubbing, the hub or shaft may be misaligned. If the sound is more of a metallic sound, the hub may be contacting the pressure plate during rotation. Manual release. For larger models of RNBZ, RNB, SNB, and MNB brakes, The cover plate contains 3 tapped holes. Brakes can be manually released by inserting the appropriate metric screw into the 3 holes. Once the screw touches the armature, the brake will release with approximately another 90-degree turn. Take care not to over-tighten the screw beyond the point where the armature contacts the field, or this will damage the cover plate. Maintenance. Under normal use, the brakes should not require any maintenance. Brakes required for holding only, RNB and RNBZ, cannot be adjusted. All MNB series and the larger SNB 1 through 10 can be adjusted for wear. To reset the gap, loosen the inner adjustment nuts under the brake cover plate. Tighten the outer nuts until the proper air gap is set, then tighten the inner nuts against the cover plate to set the gap. Make sure that the air gap measured at all 3 adjustment points is within 0.5 millimeters of each other. Specific gap and adjustment range is as shown. Contamination. The brakes are to be used in dry environments only. Contaminants, such as oil and grease, should not be permitted to contact the friction surface at any time. If the friction material becomes contaminated, the brake will probably need to be replaced. Do not attempt to disassemble the unit. The spring is under high compression and can cause harm if released. Troubleshooting. Spring-applied brakes are very simple. They are normally on or off, but there are a few things to check if you have issues. Brake will not release. First, check if proper voltage is going to the brake. Check power supply and check leads going to the brake coil. Air gap too large. Brake friction material is worn down. Check air gap. Pressure plate blocked. Check to make sure there is nothing wedged between the pressure plate and the coil housing. Defective or damaged coil. Check the ohm rating on the coil. Friction material swollen. Check to see if friction material has been damaged by water and is swollen, preventing release. Brake will not engage. Check the voltage to make sure voltage is being turned off to the brake. Make sure pressure plate is not blocked. Check to make sure there is nothing stuck in the brake blocking the brake, or make sure there are no release screws tightened down. Delayed release or brake torque too low. The air gap is too large. Check the air gap. Voltage being applied is not releasing brake. Check voltage. Oil or grease on brake surface. Check for contamination. If found, install a new brake. If brake has failed due to grease or oil contamination, it cannot be cleaned and must be replaced.